Right then, so today we're going to cover cloud computing from Amazon Web Services. This is what we're going to do. We're going to understand what a course would cover as a vendor. We're going to have a live instructor training on Saturdays. It's basically a 24/7 technical support covered for every training you're an individual is subscribing for. The classrooms are recorded so that it can be downloaded and viewed later. You can reschedule classes if you're not available, just in case. And the best part about this is you have materials available lifetime. So as long as you hold a subscription, you can download the content. Then yes, you will be eligible to write certification once you are completing the training on AWS. Today we're going to cover module 1. This is our agenda. We're going to understand what is cloud computing all about, what different ingredients are required in the cloud computing to make cloud computing working. Now, according to Wikipedia, they talk about different kind of cloud providing services. We have desktop as a service, we have software as a service, infrastructure as a service, hardware as a service, software as a service. These are all numeric jargons which are available in the market. But all this means is you have a centralized location where you have the infrastructure built and you have all the automated software built in and around the infrastructure, and it is remotely catered to the end user via internet. So in a nutshell, this is what cloud computing is all about. Advantages of cloud computing, we talk about cost reduction. So in a nutshell, to explain you how it is so cost reduction is, in a traditional approach, you end up buying the hardware, then setting up the hardware services, cooling solution, hiring IT laborers, then software costs, licenses, so forth. The idea is even before you start your business, you end up investing on a capex cost just to build a data center, and it might prolong from 12 to 18 months anytime. Now, cloud would simplify that. What happens with cloud is you go with on-demand model. That means you rent an infrastructure virtually on an hourly basis as long as you want. And when you don't need it, you can terminate this infrastructure. That is how you do not own the cost of ownership, and you could pay only for what services you use with the service provider. Scalability, yes. Assuming that you run a small e-commerce website where you do few thousand users a day, and drastically there is a holiday season where the users would drastically grow. Now, in that point in time, the infrastructure becomes very expensive because you need to have expensive IT team taking care of your infrastructure, helping you scale that and then manage that. What Amazon does is Amazon has a built-in auto scale capability. So it will understand that there is a huge requirement happening and a lot of users are hitting the server. It will automatically understand the requirement and start scaling as and when the infrastructure is needed. When the interval is done, when the users are disconnected, the server will quickly understand that no longer additional infrastructure is needed. It will start decommissioning virtual service. That is what scalability is all about. It can scale up as long as you want. When you don't need them, you can scale down and bring back the infrastructure to the original state. Backup and recovery is now automated. Now, backup plays a very critical role. Imagine in a production environment, you have massive transactions and IOs are happening. So it's very important that you do periodical backups just in case if something goes wrong, if your server dies, you can always go back and restore those backup data. So these are the couple of best practices where even in the virtual world people follow that, and even on the cloud world people follow that. Then moving ahead, convenience, yes, as long as your digital devices are connected to internet, you can access this application. Cloud basically is not new. It was there for the last 10 years. Previously, we used to consider that cloud as a virtual technology, and virtual technology is now mature to be a cloud. You had Yahoo Mails, Gmail, eBay, a bunch of other services which could access 10 years ago. It is still the same. As long as your devices are connected to internet, you could access this application. Increase in efficiency. The idea here is you do not incur licensing costs. You do not occupy yourself buying those subscription licenses even before you start. Most cloud providers have already pre-built most complex and expensive softwares, and industry best practices are involved with the software here. So you don't have to spend money buying the software and running them. You can rent those softwares. The best example is Salesforce. Salesforce is a SaaS vendor where you don't buy a software, you probably rent per user per license per month. The similar models can be replicated on Amazon where you don't have to buy expensive software, you can pretty much rent those softwares through Amazon. Increase storage capacity. The idea here is to, as and when the data grows, you can always scale your storage up. When the data is no longer required, or probably you archive them and you move them to Glacier, you can bring the data size down. Data is scalable here. So in a best environment where consumers are growing and a lot of transactions are happening, the data volume grows, velocity, variability, different version of data is grown. So we need a strong storage capacity. So we have two storage types which are available on the cloud. One is your SAN implementation, which is storage area network, and the other one is NAS, which is network attached storage. So different kind of storages are available in the market, and both are supported via cloud. So based on the price point you're looking at, and then critical and non-critical, and real-time access, non-real-time access, frequent data required, non-frequent data required. Based on these practices, you can make sure that which storage solution you choose. You can scale up, you can scale down, and you only pay for the amount of gigabytes you consume. Then we talk about global access. Again, it's all about convenience. As I told you before, as long as your devices are connected to internet, you can access this application. So technically, yes, it is global access. But again, there's a critical challenge here. Not all applications are globally available. There's some content delivery networks which might not be globally available. But otherwise, your web-based, Web 2.0 based applications can be accessed through your web browser using an internet. Environment friendly. What Amazon has done is Amazon has built a lot of automation in that. A lot of efforts are involved. You don't have to start anything from ground up. You basically look for what kind of services you want, because most of the services are pre-built and business ready. To give you a quick example, we have Redshift, we have MapReduce, we have SES, SQS, bunch of other queuing services we have pre-built as an app, and you will only consume as an app, and you will only pay for the transactions which you produce with the application. Otherwise, you don't have to worry about building up. So in a technical environment on VMware, you take a VM and then you install a middleware, and then you install the application, then you optimize the whole stack, then you test that, and then you probably move into production. So there's a time involved there. But here, environment is pre-built for you so that you quickly pick up and start working on that. Cloud computing challenges. People talk about securities and privacies, that they started assuming that cloud is no longer secure, it's no longer private implementation there, only because the data can be accessed by somebody else. That is partially incorrect. It again depends on the scope of implementation you're looking at. There's a private implementation where you can in-house your database services all by yourself, or you can move your data to a public, database service provider. Second thing is, when you talk about securities, there are two kinds of securities available with cloud, especially with Amazon. Amazon uses hardware firewall, so there is no way that somebody can breach the security. But otherwise, there are a few converge-based cloud providers who are using software as firewall. There might be critical risk with that, but there's a technical team who's managing the solution and monitoring to make sure that there is no breach with the security system. Then dependency and vendor lock-in. Amazon follows industry best practices. It doesn't believe in vendor lock-in, so there's no mutual contracts you end up signing with. You only pay for the services you use for number of hours you have used. Otherwise, you're free to terminate the services, and you're absolutely not locked in with any contract with the Amazon vendor. Data location. Amazon currently offers services in 9 countries, where one data center is reserved to US government. So technically, it operates in 8 countries. Depending on the latency in the closest country available, you're free to choose a data center, and then you can implement your application. And the best part about data localization is you can transmit data across multiple data centers for archive and backups. Just in case if one of the data center goes down, you still have the accessibility from the other location. Now, due to some privacy norms in Europe, the vendors doesn't allow Amazon or any other third-party service provider to move the data outside the region. So you have to maintain the data within the region. So that is why data localization is advantageable for any individual for a low-cost backups. Limited control and flexibility. Yes, Amazon doesn't allow an organization or a third party to get a root access to their infrastructure. That is something which is not been given to anybody. So you do not have the root access, but it is still enough that IAM, identity and access management, give you maximum privilege to modify or rebuild or choreograph your infrastructure all by yourself without even getting into the root access. That is what more flexibility I would probably call it as. Destructive recovery. Since we have across region data transmission happening and we have multi-zones built up, that would be a piece of cake because data is replicated into multiple locations. If one goes out, the data can be pulled from the other location. Regulatory and consulting restrictions, as I told you before, when I was discussing with data localization, European countries do not allow the data to be transmitted or moved to other location. They want the data to be hosted in-house. That is why we have Amazon Ireland Data Center, where we can localize the data and keep the data within the organization. So that is one thing we can do. But where Amazon is not operating, let's say that in India Amazon is not operating, So that is where our challenge is, where we won't be able to use Amazon if Indian government asks us to keep the data within India. Cloud computing application, cloud sharing services, cloud platform services, cloud infrastructure services. These are basically best practices what these guys are talking about. These are a couple of hosting implementations what operators are doing today. You have different kind of hosting environments. You can either have a consolidated hosting environments where multiple applications are hosted on one single server or on a multiple server. It can be either a multi-tenant implementation, multiple applications are running parallelly, or on a single server application are running parallelly. So in both the cases, there might be a possibility that you would indulge with. Now let me give you a quick example. GoDaddy is another hosting service provider where they use multiple servers to host multiple applications. So that if one server goes down, the applications are moved to other server and there's a business continuity given to you. And pretty much they promise you 99.9% SLA. But there are also small hosting providers where they host multiple applications on one server, and if the server goes down, the application takes the downtime, and possibly it might take some time for them to restore the server and get your applications live and running. So this is a specific architecture example here. This is basically a basic level architecture where it's talking about shared host and multiple application parallel running on an environment. Virtualization and cloud pyramid. We talk about how a data center is built from a ground up. We first talk about hardware, which is missing here. We talk about different kind of hardware. When we talk about hardware, we talk about x86 architecture-based servers. We talk about RISC servers. We talk about power-based servers, which are designed to handle different data loads. Second thing is we talk about a network here. The third thing is we talk about different storage services which are available. When you put together, it becomes a raw hardware, what we call it as infrastructure as a service. Then what we do is, as a virtualization approach and an approach of return on investment, we convert a one physical host to multiple virtual hosts. So one single server will act like a multiple physical virtual service where more than one applications can be installed and ran from a same physical host. But when you talk about cloud, cloud actually works opposite of that. What cloud does is, instead of converting one physical host to multiple virtual, it converts multiple physical hosts to one virtual. That is what we call about scale-out architecture or auto-scaling, where it can scale across multiple servers when the resources are required. But in VMware environment or a virtualization environment, we do not have that capability. We have an alternate capability called high availability. If the application server goes down, that application server is moved on to another physical server and it's rebooted. In that scenario, there is a possible downtime available. But on a cloud environment, since it is scaling across multiple physical hosts, there's absolutely no downtime encountered. Then we talk about cloud foundation. Then we talk about cloud explanation and hybrid cloud and so forth. The set of clouds which are available. We talk about private cloud. We talk about public cloud. We talk about hybrid cloud. We have community cloud, which is driven by Amazon today. So basically, the only difference between these clouds is all IP addresses. So as long as there is no public IP address associated with any of these, all this infrastructure becomes private. The moment public IP addresses are associated with this becomes a public service, right? And then the hybrid environment is where a partial infrastructures are given private IP and partial is public, where partial can be accessed through a VPN and partial can be accessed through a public gateway. So it again depends on mix and match of infrastructure design you want to play around with. So this is basically a basic diagram which is available, but you can do a lot more explanation than this design. What is virtualization here? We're going to talk about how virtualization works. As I told you before, you have one physical host. Then you convert those physical hosts to multiple virtual resources. Now to give you a quick example, how many we can convert? Now let's say that you have an HP box where you have two physical cores, two physical processor, and each processor has 8 core. So in combination, 8 plus 8 becomes 16 core. But each core will have 2 hyperthreads built into it. So that means one processor will have 8 physical core and 16 virtual core. So in a nutshell, I have 2 processors that become 16 physical core and 32 virtual cores. Now what I can do is, using VMware or a Citrix virtual platforms or KVM or any platform you guys are comfortable with, we can divide CPUs into multiple VMs. So we can take one single virtual core and we can install 10 VMs on top of it. So when you refer a VMware paperwork or paper document there, they clearly say that one physical server can host up to 320 VMs. But in a real world, it is not possible. You can just build blank VMs on top of it. But when you're moving into production, you definitely want 1 or 2 cores dedicated for performance. So I would say probably 60 VMs is what in a maximum production environment we can build.
Sohail, Can you hear me?
SDK, yes. What
Yeah.
is a diagnostic?
So can you hear me?
Yes, I can.
Yeah. So I want you to have a look on the chat box also. There are some questions for you. So I want.
Yes, what is diagnostic scaling?
Yeah. So
Diagonal scaling.
please have a look at the chat in between the demo class. Okay.
Yes, I will do that. I was assuming that I would rather answer this question at the end of the session, but if you want me to interact now, I'll do that. Now, I am not sure what you're talking about a diagonal scaling. We have horizontal scaling and vertical scaling in cloud. When you talk about vertical scaling, we are vertically building multiple virtual machines. If you're talking about horizontal scaling, we are adding more physical hardware to it. So these are the two scalings which are available in the cloud world. Diagonal scaling, I'm unsure what you're trying to emphasize on. SDK is used, yes. There is software development kit used for different services. We have strong APIs which can support PHP, Java, where you can integrate with your application or your control console and you can monitor, you can control the app, right? Or you can build a push-based notification services where using your app, you can also control the whole Amazon infrastructure. Yes, we can do that. The best example is your Android application implementation. So if you want to build an app which can control the whole Amazon, or maybe an application which is built on the Amazon, yes, we can do that using an SDK and APIs. Did I answer your question? Thanks, Phil. Okay. So moving ahead, we're talking about removing hardware links with IT operation leading the capital cost. Going back to the first part, as I told you, since you do not own the hardware, you only own the VMs there. So absolutely it's a cost reduction where you're renting the services, where you do not own the cost of ownership, and when you no longer need the services, those can be terminated and you will only pay for what you pay, what you use. Reduce operational expenses since the whole control panel is automated and most of the applications are pre-built for you. There is no huge IT labor is involved here to build, so there is very less operational expenses involved here. Second thing is, since most of the best practices are already built into the application, you do not have to bring experienced resources to deliver the results. Third thing is, it's energy efficient and it's cost effective, no licensing cost. So all this plays a very vital role in terms of saving you cost when you're beginning with infrastructure. Now there's a very famous book written by Eric. It's called The Lean Startup. It clearly says that Amazon offers you enterprise grade infrastructure at the cost of a peanuts. So when I say the cost of a peanuts, Amazon offers a server 6 rupees an hour. So it's technically it's very, very, very cost effective is what I can say. Type of virtualization, Amazon uses Zen hypervisor. Zen is an open source platform which is partially supported by Citrix. So what Amazon has done is they have taken Zen platform, they have re-engineered the Zen platform. Now they renamed it as ParaVirtual. That is what Amazon is doing. Amazon uses Cisco-based iOS network virtualizations. It has a MIMO, multiple in, multiple out. It supports 40 gigabytes port for every connection within the infrastructure. VMware is basically an enterprise private cloud software vendor. They do not have public cloud implementation, either they have the product which can be used as a public cloud provider. It's purely for an enterprises where they wanted to build a private cloud and host it inside is where our VMware products and tools are deployed. But when you're moving to Amazon, you don't have to worry about VMware or Citrix because Amazon has their own proprietary management console built. Service orchestration architecture. Different ways of building different services available. Now on an e-commerce environment, you need high availability based application. But if you're talking about stock exchange, then you probably talk about performance. So when you talk about orchestration here on the infrastructure, there are two ways where I look at it or maybe the organizations or CIO look at it. One is managed workload, one is performance. If you are a gaming firm or if you are an online content delivery firm like YouTube or maybe a stock exchange company, you would rather look for a high performance based application. Otherwise, any application like CRP, CRM, ERP or other applications can always be a managed workload. Now to give you a class example here, why we are talking about managed workload when people are talking about performance, higher clock speed and so forth. Now, in an example, let's say that on the right hand side you have a car and on the left hand side you have a bus. Probably a bus can cater 50 people, but a car can cater only 5 people. If a car has to go back to town and come back, it might take 30 minutes, but bus can take an hour. But bus is carrying 50 people and car is carrying 5 people. If a car has to pass 50 people right now, it will end up spending 2.5 hours. So this is what a managed workload is all about. Performance is only for short time. but managed workload is a non. So managed workload can process higher bandwidth of data, but it will process slowly. Performance can do the efficient rate, but it cannot carry maximum data. So on a virtualization environment or maybe on a cloud environment, when you're building the application, the primary goal is to build managed workload implementation where a volume amount of data can be moved in and can be processed at once instead of moving small chunk of data and trying to get higher performance. A service can be implemented, yes. We have .NET, J2EE, Java. Basically, we're talking about Java. We have PHP, Ruby on Rails. Since Amazon is open cloud, no matter what technology you know, even if you know COBOL and Firefox, Fox Pro, which is about 20 years old technology, you can still bring in and you can still implement that on Amazon Web Services. Unlike like your Windows Azure only supports their portfolio, Windows portfolio and only Windows products, and they shy away when it comes to non-Windows products or some open technology. So that is the great advantage what Amazon has, where organizations doesn't have to adopt to new technology only because they are moving into cloud. So the technology what they are inherited for a couple of years right now can be taken to the cloud, can be seamlessly integrated into AWS. So that is the services what Amazon offers. But since Amazon itself is a web-based services, it has open standard. It uses SOAP, it uses REST, it uses most of the open protocols. So anybody who comes from an open source background can explore a lot of opportunities with Amazon. Amazon doesn't have any proprietary implementation when you talk about API and web services integration. So that is one best area what Amazon offers where no other vendor would offer. And we talk about communication, single computing, internet, various platforms, software applications written in various programs. It's basically a game of a middleware. Now let's say that there are only 2 or 3 platforms which are available in the market. One is Windows, we have Linux, and we have Unix. So all these 3 platforms can have any form of a middleware. Let's say that you would like to install Java application on Windows, so you can use VAMstack or JBoss or Tomcat, or if you want to install .NET based application, you can do that, right? So these are basically a cross-platform middlewares which are available in the market, which can be either installed on Windows, Linux, or Unix. So once you have the middleware in place, then it doesn't matter what technology the application is built into. It can be hosted on any of the application server. We did talk about SOAP a while ago, previous slide. There is one slide which is missing called REST. REST is one thing which we need to look at it. We talk about UDDI, which is no longer supported. WSDI also is no longer supported. The only 2 protocols what AWS support is your RISC and your SO protocols are what it is supported. It also supports XML API call and HTML5 API call. So there's a couple of APIs which are part of an open standard which it supports right now at the moment. What is Amazon Web Services? Amazon Services is a collective of different infrastructure, different software, and different automation scripts put together is what an Amazon Web Service is all about. When we go back in a previous session, we talked about Amazon Web Services and we talked about 26 different services what Amazon offers. We have database services where we talk about SQL database. We have NoSQL database services. We have Hadoop, we have Cassandra, we have HBase right built into Amazon. We have Redshift, which is a real-time data warehousing product. We talk about email marketing solution. We have queuing services. We have virtual private cloud implementation. We have data center integration. So what Amazon is basically all about is Amazon was an e-commerce company. They inherited their best practices and they came up with the solution to cater other enterprises in the market. So that is how the Amazon emerged. And one of those services are pre-built put together is what Amazon Web Services is today. Amazon cost efficiency, Amazon credibility, flexibility, security. Again, we are repeating the same slide here. We did cover this part. We talked about flexibility, how flexible it is. You don't owe the ownership of anything. You only rent the services. Maybe for an hour, if you choose to use, you continue to use that and you can terminate the resources. That is how the service is flexible for you. Cost effective, since you're only using for an hour, you only pay for an hour. Elastic and scalability, yes. As I told you, if you're a small SME or an e-commerce company or maybe someone who's dealing with consumer B2B or B2C where you expect volume on your portal or on your site and you decide to scale up, it can be done automatically using auto scaling. Security, since Amazon uses hardware firewall, it's pretty much next to impossible for someone to jeopardize security with Amazon Web Services. And then its credibility, Amazon is there for the last 13 years. They pioneered their business in e-commerce via books, and then they got into so many retail markets. And finally, they took their best practices as a cloud provider, is what Amazon Web Services is today. We are only trying to focus two services here. EC2 stands for Elastic Cloud Computing, ECC. So a quick short form is EC2. And S3 stands for Simple Storage Service, SSS. So we have abbreviated the small short form. Now what EC2 does is, EC2 is basically a virtual environment where virtual machines are built, hosted. It can be either a Linux, Windows, or a Unix-based virtual machines. S3 is a block storage system where multiple redundant storage are connected to each other, and the data can be stored as a redundant file format, and these data can be used for frequently access. You can make it public, you can share this data, or probably you can use this data for your frequently access part. That is what an S3 and EC2 is. EC2 is a virtual service where you can build application server, maybe a database server if you chose to. However, Amazon has their independent database services called RDS, right? Or maybe some kind of an app engine, or maybe let's say that you want to build a WhatsApp-like services. EC2 is where you start deploying your build and release applications. Which protocol we use to transfer files on S3? See, the protocol is SFTP. SFTP is the 22 SSH protocol where we can transmit data. We can either transmit the data through browser, or we can use S3 browser, which is a client which can data be transmitted through SFTP protocol or SSH protocol. So these are the two protocols what S3 would support. The same condition will also apply with EC2. EC2 also supports both the protocols. Either you can use SFTP or SSH to transmit data. Software as a service, platform as a service, infrastructure as a service. There's something which is missing called enterprise storage as a service. S3 and Glacier are two archive-based solutions which cater enterprise as a service needs, which is missing in this slide. But apart from that, let's focus on what is available on the slide. Software as a service is basically a hosted application environment. It can be a single tenant environment. That means applications hosted on one single server, or applications hosted across multiple servers for redundancy and failover, and load balancing as an addition. Software testing takes place at the faster rate. Yes, when you take a traditional implementation approach, you had a set of division where they used to develop the software, and then the notification is sent to a tester. Tester used to test and record those bugs and then go back to the developer, and developer used to fix the problem. Now, since we have virtual environments built up on the cloud, a developer can simultaneously develop and a tester can simultaneously test, book a log there and say that probably 15-20 trackers have been found with these issues and this has to be fixed. A developer can parallelly look at it. He can reconfigure, re-engineer the program again. A tester can re-verify and go back. So instead of taking months to develop, now it takes weeks for you to develop when you're talking about SaaS development environment. That is one way to put at it. The second way of putting at it is Salesforce, where you have a hosted CRM or an ERP solution available, where you pay number of user, number of licenses per month. So if you have 10 users, you pay for 10 licenses and you use the software. So maybe you want to increase more, you can add up 5 next month, or maybe decommission 5 licenses and use the 5 licenses. So you don't owe the software. The software is built by someone else and you just use the services as a SaaS model. That is another area where you look at it. Third thing is, since the software is a hosted part, you don't have to worry about what is happening at the rear end. You don't have to worry about how will my data will be backed up, if my data is gone, or if my application is gone. Nothing. The whole data center environment, whoever is hosting the SaaS application, will take care of all the 360-degree cycle and make sure that the application is available for you. And you need to only worry about your application part. Platform as a service. Again, platforms, when you say platforms, a platform can be a Linux, or a platform can be a Windows, a platform can be an Oracle database, a platform can be a Hadoop. So these are different kind of platforms which are available, which cater different business needs, right? Now, probably you can take a Windows platform and you can host a .NET application on top of it, or maybe an Exchange server, or maybe an Active Directory implementation, right? So this can be different version of platforming when we talk about Windows. We can host SharePoint, Office 365, and it has a broad portfolio of unified communication, link services, and so forth. Now, when you talk about Linux platform, then you have the whole world. We talk about Oracle, we talk about Java Stack, we talk about SAP applications, we talk about Sage, Autonomy Automation, Vertica. So there are a lot of different applications which can cater a Linux environment. So simultaneously for a Unix also, you have different environments available. So again, it depends what platform you would like to adopt and what you want to do. But most probably platforms are used for web services and database services. Now, if you take a traditional approach, they used to take a one single platform, let's assume Linux. They used to host database like MySQL and an application server like JBoss, and then an application is hosted. Now, the problem with that platform is, if an application has to scale, a database has to scale along with that. If a database has to scale, an application has to scale along with that, because these both are tied together with one single platform, and they're using the same hardware resources which are given. So that is something which we have to unlearn when we move to cloud, where we build an independent database platform and independent application platform, which is independent of each other, can scale independently, and if one goes down, the other is there to take care of it. So this is something which, in addition, you need to involve when you're actually choosing a platform. Infrastructure as a service. What different infrastructure as a service we can participate in? We can talk about picking up hardware services on a virtual environment, or maybe we can only primarily focus as enterprise as a storage service, what Dropbox is doing today. Dropbox is integrated with S3, where it stores all subjects on S3. So apart from all these services what Amazon offers, we can play as a pure play storage player, where we offer some kind of a storage services through cloud. Maybe a Norton backup services which also use cloud to back up your data. We have Dhruva, we have Endpoint, we have so many products which only caters enterprise as a storage division. When we talk about networking, we will primarily focus on web applications, IPTV based applications, messaging services, where network as infrastructure can also be an addition for your business, or maybe an application server or a virtual servers where you can build different flavors using the platform as a service, what we have previously discussed. Now, virtualizing desktop is one other way to look at it. The idea here is to use thin clients in the desktop environment, or in the office environment, or maybe home environment, where you do not upfront the cost of the hardware, because maybe down the line after 3 or 4 years, the hardware turns out to be obsolete. But when you're using a thin client, you're actually using virtual resources through cloud or through a virtual data center, where that can be scaled up, scaled down at any point in time, and the thin clients can be prolonged for next 10 to 15 years. So that is what a VDA is all about, virtual desktop interface or integration. Internet availability, any of the cloud services are remotely hosted and may require internet all time to access. Doesn't matter what services you're accessing, but you still need internet for all the connectivities. Billing models are simple. If it is a SaaS model, it's per user, per license, per month. If it is a platform, then per hour, the infrastructure what you use, you pay per hourly basis. If it is an infrastructure as a service, then you reserve a couple of blocks of servers and you pay one fixed cost per month. Administrative task, since the whole cloud is simplified and it's automated and have involved a lot of best practices, the administrative job becomes simple since the complete platform is standardized. One individual can maintain and schedule tasks or make backups by one single console. But if you take the traditional approach, you have different environments with different technology built, where you require different expertise to take care of different jobs. But since now everything is unified, working on managed workload principles, one or two person can actually manage the complete set of infrastructure all by himself or herself. Type of cloud models which are available. Yes, we have covered this slide before. We talked about private cloud, we talked about public cloud, hybrid cloud, and community cloud. So right now, community cloud is only driven by Amazon at this moment, where they have a huge community of open source developers and contributors, where they're contributing codes and the development ideas to Amazon. That is one way where we can look at it as a development forum. Apart from that, the only differentiate between a hybrid, open, private, and public cloud is the IP address. Now, assuming that what Amazon does is when you're building virtual instances, by default, it associates a private IP address and private DNS to it. Now, these can be configured through VPC and can be accessed within your office firewall. That becomes a private infrastructure. So when these services are given public IP addresses, they are not only accessible within the office location, they're also accessible outside location. Now, to extend this example, there could be some customer-facing applications which are publicly available, like a company website. But there's also another website which is available called Employee Portal internally. So you can have two servers, one has public IP and another has private, and private applications can be accessed within the VPN tunnel, and public can be accessed to anybody using a domain name. And hybrid becomes that way. So hybrid is part of public and part of private. So the only core idea between the infrastructure is the IP address. Whether you're making this infrastructure publicly visible, then you will associate a public IP address. If you do not wish to choose so, then you can retain the private IP address, bridge a VPN tunnel using virtual private cloud, and then you distribute traffic through that tunnel throughout the time. Private cloud, it is a private cloud hosted and built in, maintained by a specific client. The similar concept also applies for a public cloud vendor as well. It doesn't matter whether you are a public cloud provider or a private cloud provider or a consumer looking for a private or a public cloud. In both cases, both are managed internally and you are not given root access at any point in time. So that is what a public and a private cloud is all about. The second thing is, since they have pre-built everything, you don't have to worry about wasting your resources, or you have application stacks ready, you just pick it up and start deploying it. So the time taken to build, the time taken to acquire, the time taken for testing is no longer required because these are all set, pre-built and readily available. New investments, we can talk about CapEx versus FX. Now, in a traditional environment where you have to in-host and build a data center, even before you start a business, you have already spent a bomb just to find a location, move in service, talk about cooling solutions, power backup, lease lines, so forth. So, a huge investment is involved there. So, to retain those investment, what we can do is we can move to a public or a private cloud provider where we're not blocking that money, and we have readily infrastructure available where we can start a business quickly. But when you talk about control required, definitely not. Amazon doesn't give you complete control, so you absolutely have no control to deal with the infrastructure. You have only identity and access management where you can take care of your infrastructure, which is what you can do, and you do not have access to virtual layer at any point in time. So you absolutely have no control when you're moving to a public cloud provider. When you talk about visibility issues, if there are some internal issues which you do not have access to fix in, Amazon might buy time and they might correct the problem. But there's no timeline given because this is basically internal infrastructure managed support where they're managing their own infrastructure, but they will not manage the consumer products or consumer services which are built on top of it. It is not fixed. Amazon is not fixed. It's a variable cost. We have different services available. We have spot requests. We have reserve instances. If you are willing to prepay the services, then you save a huge cost on the infrastructure. However, that is something if you do not wish to do and yet continue to pay for the services, you can do that. I almost forgot to look at the chat screen here. We talked about difference between a public cloud and a community cloud, right? Public cloud is where you take services from a public infrastructure provider and you pay for what are the services you use. But what community does is, since a community is driven by an open source, community, they will use open source products. So let me give an example here. Now, on a public cloud, you would like to build a CRM solution. So the idea here is to pick up a Linux instance, install a middleware application, then move in your your CRM product, then you engineer the whole product, and then you get into testing, and then you move into production. The same principle also applies for your private implementation and hybrid implementation. But what community clouds will do is, in community cloud, there are two departments which are available. One is Amazon Marketplace and one is Amazon Community Cloud. Now, in Amazon Marketplace, what happens is vendors are pre-built and make sure that the integration is done efficiently. And then these stacks are readily available so that you don't have to worry about testing, rebuilding, how will that work, when did that fail, whether it's done properly or not, the OS is rightly hardened or not, the security credentials are configured or not. All these things you don't have to worry about that. A manufacturer of the software would take end-to-end development responsibility, make sure that it's completely integrated, and he'll make sure that these stakes are ready or these instances are production ready. So someone who is willing to use a proprietary software can go to Amazon Marketplace, pay for the software or pay for the license or maybe rent those licenses, take the software quickly. In no time, you can have Oracle or SAP stack running on Amazon. But what Community Cloud does is, Community Cloud does exactly what a proprietary vendor does. But here, in a Community Cloud, they're using open source software which are freely available. Now, to give you a classic example, we have a vendor called Bitnami. Bitnami is an open source vendor who is #1 partner for Amazon Community Cloud division, where they have contributed more than 70 different stacks to the Amazon cloud where no other vendor has come that close. So these 70 stacks are all open source. Bitnami community has integrated, pre-built, and they have made readily available. And the best part about that is, since the software is free, integration is free, you only pay for the resources you use. So you have pre-built stacks which are done, contributed by Amazon community, which is now driven by Bitnami. So like Bitnami, you have Trunky Linux, you have a bunch of other guys. There are some of the contributions which are done by Apache Foundation, right? But the #1 is Bitnami because Bitnami contributed 70 plus stacks to the community cloud. So you have varieties of stacks to play around with, from the CRM to ERP, or maybe from e-commerce to employee portal, from your sound sharing till file sharing. So all these open source programs have built a part of a community. So picking up a stack from a community cloud is where it will reduce your time of building your own stack, testing it and deploying it. These are pre-built, tested and readily available, and it is free also. But unlike like Marketplace does the same thing, but here it's all proprietary software and proprietary vendors are charging subscriptions for the services they offer. So again, it depends. If you want to go with Community Cloud free edition or a Community Cloud paid edition, it's all up to you. That is what a Community Cloud is all about. Hybrid cloud, private cloud, public cloud, no difference. The IP addresses are the only game here. So a part of the infrastructure can have public access. A part of can be having a private access, becomes a hybrid cloud. Otherwise, it's individual or public or a private. That is what the difference between the public hybrid clouds. Then going back to variability cost, lifecycle automation, knowledge management. See, the worst part about Amazon is Amazon doesn't offer you managed support at any point in time. However, if you choose to have one managed support, then it will cost you roughly about $400 per server. So that is a very expensive services you would want to choose. Otherwise, you have someone who's trained on Amazon, certified on Amazon, who can able to manage, automate the infrastructure. Maybe choreograph is what I call it as a right word. Who can choreograph the infrastructure, use right resources put together, and making sure that the resources are put together does not exceed the budget. Make sure that the right resources are put, capacity planning is done, efficiently cost calculation is done, return on investment is decided. So someone who is trained on that would be an addition for building applications on public or a private cloud, or maybe migrations also. Now, Amazon has two services. One is called Direct Connect, and the other one is called Gateway, Storage Gateway. Now, Direct Connect, what you could do is you can extend your data center to Amazon data center, where you no longer have to build a new data center. You can extend the data center and you can integrate your services with Amazon infrastructure, and you will only pay for the resources what you're consuming. Likewise, Storage Gateway can also be extended your storage solutions, where if you're running out of storage and if you want immediate storage solution at the lower cost, you can integrate your services with Amazon and you can use their sandboxes and NAS boxes for your utilization. So these are the other ways of migration. Third thing is, again, we talk about data migration. We have two types of data migration. We can talk about Oracle or structured data rather, and unstructured data. So the structured data, you have to use Oracle Gateway, Gatekeeper, and then you migrate data. Or you have different best practices of using the data migration concepts. But when you talk about NoSQL, it's basically you create those governance and you move it to S3 and then you process to MapReduce and so forth. So there are different techniques involved to migrate different infrastructure types, right? There's no standardized process which is available. I think this is the end of the session. So this is a quick understanding about what cloud is all about, what cloud is doing today, how is the cost benefit, how is the licensing involved here, what are the pre-built stocks available, how you can utilize your community cloud for your advantage, right? However, if community cloud doesn't serve your purpose, then we can move to a proprietary cloud called Amazon Marketplace, where we can build or pick up a paid stack or enterprise-led applications like SAP or Oracle, and then we can deploy for our businesses. So there are huge benefit from a community. You can either associate with a free or a paid. There's a huge benefit with public or private implementation based on the requirement. If it is a consumer facing, then it turns out to be a public. If it is an employee facing, then it turns out to be private. And if you are in a business where you need to have partial public and partial private, is where you move into hybrid implementation. So there are a lot of things to talk about in a nutshell, but this is a quick overview on what a first model should cover.